Hi, I'm Lake Speed Jr. Total Seal Piston Rings, and we're back here at L Engineering to talk about ring seal, one of my favorite topics. And I like to use the analogy that ring seal is kind of like making soup. It's not just about the broth, not just about the chicken or the vegetables or the spices. They all have to come together to make the soup. And you're saying, what does soup have to do with ring seal? Quite simply, ring seal isn't just about the piston ring, or the piston, or the cylinder bore, or even the oil. All four of those elements have to come together to create proper ring seal. The most important one of that is actually the cylinder bore. Two things about that are very important. Number one is cylinder bore finish, the actual surface roughness. Because you see, when you're talking about ring seal, and you may be wondering, what does oil have to do with ring seal? Essentially, motor oil is the gasket that goes between the piston ring and the bore, and the piston ring and the piston ring groove. You wouldn't put together an engine and not use a head gasket or a valve cover gasket. You have to have gaskets to fill the gaps between those two hard surfaces. Oil is the gasket of ring seal, and that cylinder wall finish is what holds the oil. If it was completely smooth, mirror finished, there would be no valley to hold the oil, and blow-by would be terrible, and the lubrication would be horrendous. The rings would be destroyed because there's a lack of lubrication. So having the proper surface finish, enough valley to hold the oil to lubricate the ring properly, is essential. But if the finish is too rough, too much valley, now oil control can be very bad and blow-by can be bad. It's kind of like Goldilocks and the Three Bears. Not too much, not too little, just right. Here at L Engineering, they have the tools to measure the surface finish to make sure it's correct, and also the tools to make sure that it's straight and round. The cylinder wall needs to be straight and round. The piston ring needs to be round. We're going to measure it later in another video. We're going to do what's called light tight checking to see, does the piston ring match the cylinder wall perfectly so that light cannot escape. When you have perfect seal, you get what you're looking for. Total seal. You want that piston ring to be sealed up properly. That way all the combustion pressures are acting on the piston, creating power and not blowing by into the crankcase, which is going to kill your motor oil. So again, the key thing is measuring the surface finish using the profilometer. The RA, RPK, RVK numbers that it produces characterize the roughness of that surface. The Sunnen bore gauge is used to measure the cylindricity, how round it is and how straight it is top to bottom. You don't want a cylinder doing this or doing that or doing this. Now the rings can adjust to some degree, and there's going to be thermal expansion that will change some. But overall, you want a bore that's straight and round so your piston and your ring can seal it up properly. So now that we know that our ring seal soup involves the surface finish and cylindricity of the bore, the piston, the ring, and the oil all working together to create that good ring seal, now let's move on to the next video where we discuss the next factor, which is the break-in process. We're going to give you recommendations on process and products to use in order to make sure that soup comes together to give you the taste you're looking for. Thanks for watching.